2000 Toyota Rav4 EGR system. This is going to be a long video because we're going to step through information from all these documents. We got the FSM, we got the wiring diagram, we got the diagnostic manual. We also have this document, which is the general emission subsystems document from Toyota. And I'm going to give you a detailed explanation of how the EGR system works on the Rav4. Also have some extra parts, so we'll be able to set up a little mini EGR circuit on the bench. So check the timestamp so you can skip around to where you need to be. Up first, I'm going to go through the entire EGR circuit, both the vacuum and the exhaust sides, and show you how each part works. Once you have an understanding of how each part works, the EGR system will make sense to troubleshoot. After that, I'll do about 8 or 9 in-engine tests of the EGR components. If you're troubleshooting right now and you just need to see some tests, go ahead and skip ahead to that part. I'll put up a timestamp. After the in-engine tests, I'll show the full bench testing procedures for the EGR valve, the VSV, and the EGR vacuum modulator. And finally, at the end, I'll set up a little mini EGR circuit on the bench to show you how everything works and to make troubleshooting a little easier and more visual. So skip around as you need to. Up first is what the EGR system is and how it works. So here we go. EGR stands for exhaust gas recirculation. And what that means is that some exhaust gas, so this is the exhaust side of the engine on the Rav4, this is the intake side of the engine, some of the exhaust gas can be recirculated back into the intake, so they can be moved back into the combustion chamber to be reburned. The purpose of this is to reduce NOx emissions, which is nitrous oxide. On the Rav4, it also plays into fuel economy because the ECU can change the spark advance depending on the EGR conditions. So if you have an EGR problem, you won't pass your emissions test and you may be getting very poor fuel economy. So physically what's happening with exhaust gas being recirculated is this is the exhaust side of the Rav4. This is underneath here is the exhaust manifold. And there's a little hole in the head, and that hole allows some of the exhaust gas, instead of going down through the catalytic converter and down out the muffler and out the tailpipe, some of that exhaust gas can actually make it back into the intake. And the way it gets there is there's a hole bored in the bottom of the head. That hole goes all the way across to this side, and then there is a pipe. I'll show you in a second. That pipe comes from the bottom of the head and goes into this device here. This is the EGR valve. I'll show you the pipe. If we just come in on this side of the Rav4 engine, we can see that pipe right there. See this pipe here? That pipe, if you follow it down, it goes into a hole in the head. You can see it over here, right down there. And there's a nut, and the nut just tacks that pipe down into that hole in the head. So that is physically how the exhaust gas is getting into this thing, the EGR valve. So this is the EGR valve. Exhaust gas is going into the bottom side of that. As the name suggests, that's a valve, so that will open and close. And as you can see, that valve is tacked on right here to the intake manifold. So I have one in my hand, and you can see exactly what it looks like. That bottom side is where that pipe bolted in. And then here we have an opening, and you can see in there there's a little pintle. And if I apply vacuum to this port, which we'll do later, that pintle should move up. And when that pintle moves up, it will allow all of the exhaust gas that's in that pipe to go ahead and get sucked into the intake. The intake is always going to have suction in it, vacuum, when the engine's running. So as soon as that pintle opens up, it's going to suck that exhaust gas back in. So that's how the exhaust gas ends up back in the manifold. It has to make it through that little pintle. So let's take a closer look at that pintle. There you can see the pintle is down. And what I'm going to do is I'm just going to put a hand pump right here, and I'm going to apply some vacuum, and we're going to watch that pintle rise up. So I'll just take the vacuum hose and put it on right here. And what I'm doing now is I'm just replicating this part of the circuit, this hose here. If I take it off, that's that same port. So try to keep an eye in here on this pintle. As I apply vacuum, that pintle is going to move up. So here we go. See that? It's barely moving up. We look in, moved up a bit more, and now you can see we definitely have a passage there. You can see that little reflection from the light. And if I keep applying vacuum, it's going to max out, and there it is, it's maxed out. And at this point, I can keep adding vacuum, it's not going to travel up any further. So that is the maximum position on that pintle there. And anytime the engine's running, we're going to have at least some exhaust gas here making it. Assuming that there's not an obstruction in the pipe, we're going to have exhaust gas getting here. So if that pintle opens when the engine's running, exhaust gas is going to make it into the intake manifold, and that's exhaust gas recirculation. So we can see if we have vacuum on this port up here on the EGR valve, the EGR valve will be open. So your next question is going to be, well, how do we get the EGR valve down? And for that, we just release the vacuum, and you can see that EGR valve went down. So now you know that we need two things at this port here. We need vacuum to get the EGR valve up, but we also need a way of removing the vacuum, venting the vacuum or stopping the vacuum in order for the EGR valve to go down. So that's going to play into one of the next components in the circuit. Before I show you that though, you probably noticed this port on the EGR valve, and you're probably thinking, now that's interesting because it almost looks like it's lined up with that hole there. And if you look inside, we can see that it is. See that 90 right there? For that port. So this port on the EGR valve is another path for exhaust gas to go. So if exhaust gas is coming in here, it will, and this pintle is closed, all of that exhaust gas will end out here. If the pintle's open, some of it will end up in the intake, and then some of it will end up going out here. Where this goes is to the EGR vacuum modulator, which is that component right there. And it goes in just like this. If we look on the bottom of that, we'll see there's a hose, and it connects just like this. So some exhaust gas is going to end up on the bottom of the EGR vacuum modulator. We'll get into that in a minute, but what this tells us is that there's two sides to the EGR circuit, so to speak. There's the vacuum side, which is the vacuum hoses on the top here, and then there's the back pressure side, which is that pipe going into the bottom of the EGR valve, and then the little hose going into the bottom of the vacuum modulator. So I'll just call this the vacuum side, and I'll call the bottom side the back pressure side, exhaust back pressure side, or the positive side. Where we're going to go right now is back to the EGR circuit. We're going to go to the next component on the vacuum side, which is the VSV, or the vacuum switching valve. Now this next component on the vacuum side of the EGR circuit is in a really, really crazy place on the Rav4. If we follow these hoses down, this hose here, this hose goes into one side of it, and then this hose comes out of the other side of it, and it's a little component about this big called a VSV, or a vacuum switching valve. That VSV is on a difficult to reach spot on the Rav4 because it wasn't so bad on the other 3SFE and 5SFE engines. It's in the same location, but on the Rav4, because the body's different and all, and especially on the four-wheel drive Rav4, there's a transfer case and the CV axle's different. It's tough to reach the VSV, but it's all the way down here, and it's bolted towards the bottom of the head. And like I said, you can find it by following those vacuum hoses. Check out my VSV video if you need to locate it and move it. I moved mine, and there it is where I moved it onto the firewall. It's what a lot of Rav4 people do because it's a lot easier to get to. But that there is what the VSV looks like, and you can see those hoses going into it. So now we'll focus on this component. So I just undid that mounting bolt and disconnected the electrical, and so just the same as it would be on yours, you're just pulling on these hoses. This is what the VSV looks like, and as you can see, it's just great big long hoses that go into it. So this VSV is interrupting vacuum between the EGR valve and this Q port on the vacuum modulator. All I'm going to do now is just disconnect these hoses. You see this one with the white band? I'll just pull that out. That's the same hose as this on the EGR valve, the white band. So I'll just pull that out. And the yellow band on this side, near the electrical connector, pull that out and pull that out. And I'm just going to come in with some shorter hoses to make this easier to see. So here I have much more manageable hoses, and I'm going to keep the same color scheme. And if you can't see the colors, that's yellow and this is white. The white is thicker. So we went yellow onto Q, and then yellow went to this side, the side nearest to the electrical connection on the VSV. And then we went white to this side on the VSV to this port on the EGR valve. So what you're looking at here is the full EGR circuit. There's no electrical connection on this right now. Obviously, normally there would be an electrical connection, but I'll explain how that works, because sometimes the EGR circuit is in a state where it doesn't need an electrical connection, and that's the case where the VSV is not energized. So recall, we're still on the vacuum side of the EGR circuit. We're going to neglect the back pressure, exhaust back pressure side for the moment. So this is where we need vacuum if we're going to get the EGR valve to lift. This device, though, is interrupting the flow to this port over here on the vacuum modulator. Why didn't Toyota just run a hose, straight from the vacuum modulator to the EGR valve? Why would it run it through this electronic device? Well, as the name suggests, this is a vacuum switching valve. So this has the ability to cut off vacuum. Remember when we were looking at the EGR valve and we knew that vacuum was going to be what pulls it up, but we needed to cut the vacuum out. We needed to release the vacuum in order to get the pintle to fall. This is one way that we can release the vacuum. What this is there's a little solenoid inside. And if we take this hose off here, and if I were to take this off, I'm not going to because sometimes they break, but if I were to take this off, this is just another port just like that. There's a filter on here. And how this works is when there's vacuum on this side from Q, so let's say we have vacuum over here, when this thing is not energized, so just how it is now, no power to it, there's a direct connection between this port and this port. And as we know, we just had it hooked up, that port goes directly to the EGR valve. So in this situation, any vacuum on this side will make it over to the EGR valve. And just to demonstrate that, I'll throw some vacuum on it real quick and you'll see what I mean. So here I'm just going to disconnect the line at Q, which would be our vacuum source, and I'm going to plug it into our new vacuum source, which will just be the hand pump. And I'm just going to unplug here at the EGR valve, and I'll cover this with my finger. And if we can pull vacuum across this whole thing, then we should be able to hold vacuum on the gauge. So let's see if we can do that. So here I just bring it closer to the camera. You can see I'm just going to cover up this port, which would be on the EGR valve, and see if we can hold vacuum across there. And as you can see, we can hold vacuum across there. So what that's telling us is that this VSV is airtight between this port here and that port there. And if I release my finger, you can see that it released the vacuum. What this VSV does, though, is it allows for a way for, even when there's vacuum over that line, if this gets energized, so if this gets a ground from the ECU, what it'll do is instead of having that connection between this port and this port, the solenoid will move and it will disconnect this port and open this port. This is an atmospheric vent, so we will lose vacuum on this side. So to demonstrate that, I'm just going to hook this up real quick to the battery, 12 volt in the car, and you'll see what I mean. I'm over here at the battery now, and don't worry, I'm going to go through how to hook all this up on the bench if you want to do this test on your own VSV. But it's useful to see exactly how this thing works while we're still talking about the EGR circuit. All I have here is I've got this connected here to the positive. You can see I'm just connected there to the positive side of the battery. I do not have the other end connected yet. But what I'm going to do is, before I connect anything, I'll show you. I'll put my thumb on here, and I'm going to use the hand pump to get vacuum. And that's going to show that we have, because the vacuum pump is hooked up here, that's going to show that we can hold vacuum from here to here when we are not energized. So this thing is not energized, and if I hold vacuum here across there, you'll see it can hold vacuum. But watch what happens if I move my finger. We lose that vacuum, right? So the connection between here and here is based on this VSV not being energized. Now, what's going to happen is when we energize the circuit, we're going to lose vacuum on this line. We'll still be able to keep vacuum on the gauge, but we'll lose vacuum on this line. And you'll see that because I'll be able to move my finger off of here, and we'll still have vacuum here, but obviously no vacuum in this line. So let's do that, and I'll cover this up again. And I will apply some vacuum on there. You can see there's vacuum on the gauge. Now all I'm going to do is I'm going to connect this to the terminal. You'll hear a little click if you listen carefully. You'll hear the solenoid click. You won't see, maybe just a little blip on the gauge. And then I release my finger, and you'll see it will still have vacuum on the gauge, but no vacuum on this line. So here we go. You hear that little click? Now what I felt on my finger was I felt that I lost suction. And you see, I did. This is open. So as soon as I release this, so I'm still connected here, as soon as I release this, we will lose vacuum. So that's how that VSV works. It's internally, it's changing the path. So there's a solenoid in there, and solenoids have little holes on the shaft. And that's when it gets energized, it's changing position such that the vacuum here at Q is no longer making it up here to the EGR valve. So we have vacuum across this side, but we don't have vacuum to there. So I'm just going to disconnect all of this now that we have an idea about how it works, and we'll go back over to the circuit. So I will just hook this up back now how it was. Remember, it was vacuum side Q is yellow and white goes to the EGR valve. So now we can see how the VSV works as far as its role in modulating vacuum on the vacuum side of the EGR circuit. So let's move back through. We'll continue this way on the vacuum circuit. We're going to end up here at the vacuum modulator. And now this thing is really ingenious, and this is the component that's hooked into both the vacuum side and on the bottom the positive side, the back pressure side of the EGR circuit. So here we have the vacuum modulator, and we know that this yellow band hose goes to the VSV, and then so just looking at this circuit, we know that if we have vacuum here at Q, if the VSV lets it, which it would right now because it's not energized, any vacuum on Q is going to make it all the way over to the EGR valve, and that's how the EGR valve is going to move up. Now if there's vacuum on the EGR valve and the computer decides that it doesn't want the EGR valve to be up, it can energize this solenoid, and that will lose vacuum on this line. We'll still have vacuum at Q, but we'll lose vacuum here on this line, and we won't have EGR flow anymore. So the vacuum modulator is really ingenious, and it plays on both sides of the EGR circuit. It plays on the suction side, the vacuum side, and if you remember on the bottom, it plays on the positive side, the back pressure side. Because if you look here I have one, and then holding it just like how it is there. Remember on the bottom it has this port, and that port went into this hose, and this hose went into the EGR valve just like that. So this bottom side of the EGR vacuum modulator is getting some back pressure from the exhaust, whether the valve is open or closed. If it's closed, it's going to get all the back pressure. If this valve on the pintle opens, obviously some of the exhaust is going to come in the intake, and some of it's going to end up over here. So if you're wondering why would we need exhaust back pressure on the bottom of this EGR vacuum modulator, and your first guess is because there maybe is a diaphragm in here, that's exactly right. There's a diaphragm, and that's why this can play on both sides of the circuit. It can play on the exhaust side, and it can play on the suction side, and those are the two ways that the diaphragm is moved. So let's take a closer look inside this vacuum modulator. I should mention, removing the vacuum modulator is super easy. You just unplug the vacuum hoses just like that. This is just a spring clip. You can just pull it right out of the spring clip. You don't even need to undo the bolt. And then you see there's the hose on the bottom. You just disconnect that hose there, and it's out. It's a piece of cake to get the vacuum modulator out. But I'm going to leave that one in place since I have another one. Make sure these vacuum hoses are connected back the way they need to be. So let's open up this vacuum modulator. Now unfortunately I can't take the thing all the way apart, which would be removing this band, because then I'll ruin it, because this has to be airtight. It has to be airtight between this chamber on the bottom and the one on the top. But you can kind of see some important things if you just take the cap off. So I'm just going to pry. I'm just going to turn it like that. Pry this cap off. You can see it just got some little grooves on there. And there's a filter. So let's pull this filter out. Let's pull this little filter out. And if we look on the bottom of the filter, there are some deposits. And there's a hole. So basically this side of the vacuum modulator is a planned vacuum leak, because you can see that hole there. That's on the top side, so that's the ports going in here are both vacuum hoses. The one going out is also a vacuum hose. So the only way we're going to get stuff on there is from the intake flow on the engine. So this is a vacuum leak. It's a planned vacuum leak there, or you could just call it a vent. So what this vent tells us is that we're going to need a certain condition in order for this diaphragm on the top to seal. So there I just put the labels on them so we can remember all those. Now if we look at this vacuum modulator, we know that we need vacuum on Q in order to make it to the VSV, and then whether or not the VSV is going to let it go to the EGR valve is going to be up to the ECU, but we know we need to get vacuum on Q, and we know that if we just follow these lines, those go into the throttle body. The only possibilities for the vacuum source are P and R. So if we look at this, we might say, oh look, anytime there's vacuum at P, it's going to make it to Q, because look, it goes all the way across like that. it looks like this, right? It looks like anytime it's vacuum on P, anytime it's vacuum at the throttle body on P, it's going to make it to Q. But that's not actually the case, because if we turn this and we were able to look inside, we would see that that's actually a T. That's a T connection. So what that means is that this is going to be open on the bottom. So how does it close? It closes when the diaphragm moves up. So inside here, the diaphragm, in the center, there's a little seal, a little seat. And when that seat lines up with this here, and when the diaphragm moves up, it closes that, and then we can have vacuum. Then it will act just like this, and all the vacuum that's on P will make it over to Q. So if the diaphragm is working properly, and the seat in the diaphragm, which sometimes wears out because it's a little rubber seat, if that seat's in good condition and it can seal the bottom of the T, then anytime the diaphragm moves up, it's going to seal all the way. It's going to seal P to Q, and we'll get whatever vacuum that we have at P, we'll make it all the way over to Q. So what's ingenious about this vacuum modulator is there's two ways where that can happen. There's two ways to seal the bottom of the T. In both circumstances, it's because the diaphragm moves up and the seat seals off the T. But the way the diaphragm can move up is either one of two ways. The first way is back to this side, and if you remember, that's engine exhaust back pressure. So this diaphragm can be pushed up. It can be pushed up when air is blown in here, so positive flow. When it's blown in here, it can push that diaphragm up, and when that happens, we'll be able to get the vacuum that's at P all the way over to Q. The second way that this can close from P to Q is even if there's no back pressure at all on this side, so open just like that, if we get enough vacuum on R will suck the diaphragm up, and we will get a closure between P and Q. So those are the two different ways. Two ways. So either enough vacuum on R will suck the diaphragm up, close the bottom of the T, and we'll get vacuum at P all the way over to Q, or exhaust back pressure will push the diaphragm up. Regardless of R could be open in that case. The diaphragm will be pushed up by the exhaust back pressure, and we'll get closure from P to Q. That's why these vacuum modulators are really cool, because they can work in those two different ways, and they are really modulating vacuum. That's a good name for them, because this vacuum from the throttle body on P or R or both, whether or not that's going to make it over to Q is going to be dependent upon the function of the vacuum modulator. So now the next question you'll have is, all right, now we have these two ports on the EGR vacuum modulator, and we see these two hoses going to the throttle body. What's that all about? Why are there two hoses? Why is there not just one hose? And where do these hoses go? So let's next take a look at that. There you can see I've just removed the air hose, so we're going to go down there and look inside the throttle body. Now looking back at the EGR vacuum modulator, if we follow these two hoses, this one is the one labeled R, this one on the inside is the one labeled P. R goes all the way down here, and it goes into the throttle body right next to a little mark in the casting that says R. And P goes all the way down, and that is its mark there. It's this mark E is referring to this hose. I don't know why it doesn't say P, or that up there doesn't say E, but just remember that P goes to E and R goes to R. So I'll just call these the P/E port or the R port. So now let's go and look inside here through the throttle body at the throttle plate and see if we can see where these holes actually go through. So here we are looking into the throttle body. That's the throttle plate, and at that 10:30 or so position, you can see there is a little tiny hole. And notice that that is all the way on the left. So if we come up, we know that that is this port right here, which is the R port. So what we can tell by that R port, just by looking at it, is that that is on the outside of the throttle plate. So when the throttle plate is closed, or even if it's open but not open all the way to R, you see there's a little bit of travel there that the plate will have to do in order to get past R. That means that if the throttle plate is closed or barely open, we're not going to get any vacuum on R. So looking back up here at R, we know now that we're not going to get any vacuum on R. When the throttle plate is closed, we won't even get vacuum on it until we have the throttle plate open a bit. And if you remember when we were talking about the vacuum modulator, that R port on the vacuum modulator was the port that if it had enough suction on it, it would suck the diaphragm up to close off the bottom of the T. And remember that that T was from this line, P/E, over to Q. So what that's telling us is that the R, the vacuum on R, is only going to be applied at the vacuum modulator when we're under throttle, and a bit of throttle, because we have to be past that hole in order for the vacuum to reach this line and go back and play into the role of the vacuum modulator. So what about this one? What about the P/E? Well, if we go back in here and look for it, we can't see it. We can't see it on the outside of the throttle plate, but if I just turn the throttle plate, yeah, there you can see it right there. That is right on where the throttle plate closes. It seems to be lined up perfectly with where the throttle plate is closed. So when that throttle plate is closed, it doesn't look like we're going to get any vacuum on that P/E, but if we just barely turn it, and I mean barely turn it, then we will get a little bit of vacuum on that. So looking over to the left, to the hole on the outside, that R hole, look at all the travel I have to do before I get past it, and now I'm past it, and that's when that's going to see vacuum. So what that tells us, physically knowing the position of those holes, again, this hole for R being on the outside of the throttle plate, where the throttle plate is in the closed position, and this one for P/E being right at the throttle plate, that means that if we just barely move the throttle plate, we're going to get vacuum on this P/E to the vacuum modulator. Now whether that makes it around is going to depend on some other things, but we will have vacuum here. However, we won't have vacuum here if we just barely move the throttle plate. We're going to have to move the throttle plate a fair amount. And that may just seem like a little bit of movement when you're looking at that, but it's a fair amount of movement. Now we have a pretty good understanding about how this EGR circuit works. We know that there is a vacuum side, which is all these vacuum hoses here, and the vacuum side includes the VSV. And then we know there's a positive or back pressure side, which is the hose on the bottom that goes from that one port on the EGR valve into the bottom side of the EGR vacuum modulator. We also know that these are just purely mechanical devices, the vacuum modulator and the EGR valve, and that this is a electromechanical device. We have an electronic input to the solenoid, which will cut off flow from Q to the EGR valve when this is energized. So the next question would be, well, what tells this to energize or not? As you can see, there's just two contacts there, and as you would probably guess, that's just power and ground. So this is going to be connected directly through the ECU on ground. So when the ECU wants this thing to be energized, it will go ahead and supply the ground for this. And when that happens, the solenoid will engage, and as we already saw when we had it hooked up to the battery, when this thing has power on it, we won't have vacuum here. So the EGR valve, if everything's working properly, it will fall down. Opposite way, if the ECU wants EGR flow, it wants the vacuum from Q to make it all the way over to the EGR valve, then it will break the ground on this and it will not be energized. And as we saw when we were doing the test on that, that will allow all the vacuum from Q to make it all the way over to the EGR valve and pull the EGR valve up, and we'll get exhaust gas recirculation. So how does the ECU make the call on whether or not to ground this thing? Well, the ECU is getting information from this device over here, and this is the MAP, or MAP, or Manifold Absolute Pressure Sensor. As you can see, there's a vacuum hose on the bottom of this. You can just pull that out. This vacuum hose goes right back here to the back of the intake. So this MAP sensor is supplying the intake pressure ratings, the vacuum readings, directly to the ECU. I don't know if you can see, but there's three contacts on that connection there. So that information is going back to the ECU, and the ECU is comparing it to a list of stored values, and that's how the ECU is making the call as to whether or not the conditions are appropriate for exhaust gas recirculation. Now, another factor in the ECU's decision making, so to speak, is the engine temperature, and I'm not positive that it's taking the temperature off of the engine the ECT, the engine coolant temperature sensor, but that's where I'm guessing it's coming from. But don't know that for a fact. But I do know that the ECU is considering the engine temperature while making the call on EGR flow or not, because you'll see later when we do a test, we can do a test cold and get a certain result that's a good result, and then we can do the test warm and get a certain result that's the opposite result, but it's a good result. So there's a warm-cold difference on how the ECU is determining whether or not to ground the VSV. And again, I'm not sure that's from the engine coolant temperature sensor, but that's what I'm guessing that it's from. Now I'm going to get this thing all put back together. I'll get this moved back to its location and plugged in, get the air hose back on, and we will do some tests. We'll do first the engine tests. If you want to skip ahead and just look at the bench tests, I'll put up a timestamp. Now that you have an idea about how the EGR system works and the different components in it and also the vacuum hose layout, we're going to step through some tests on the system to get some ideas. And this is a clean bill of health at Rav4, so all the numbers you see on here are good. So now we'll start some tests, and 0th test is the easiest thing. Check out the easy stuff first, which is vacuum hoses. So take off each one of your vacuum hoses and put it on your pump. Cover the other side and make sure that it holds vacuum. It does not have any leaks. So you might get lucky and it might just be a vacuum hose. So we'll test this hose here, for example. You can see that holds quite well. So that hose is good. Check all your hoses. So you're going to want to check all your hoses. The hoses to the VSV are going to be difficult to check. You'll see kind of an indirect test for those soon, where you're testing across the VSV in a couple conditions, and that can give you some idea. So we'll perhaps do that later. The other test that you need to do for the hose is this MAP sensor. Unplug both sides of this hose. The other side goes into a filter here on the intake manifold. Make sure that that is airtight, because if there is a vacuum leak on this hose, then the MAP sensor is going to be getting the wrong pressure readings from the intake, and that will be the wrong information to the ECU, and who knows what the ECU will do with that. The other thing you want to check is the exhaust leak. So check the hose that goes from the bottom of the EGR valve over to the vacuum modulator. Make sure that you don't have an exhaust leak in there, because that could lead to a P0401 flow insufficient if you have a lot of exhaust gas leaking out there. Another easy test you can do before we start getting into the more specific tests is make sure you're getting vacuum out of the throttle body in the first place. These passages are tiny. You saw how small they were. And if these are obstructed, if you got some kind of really, really dirty throttle body, there's a possibility these might become obstructed and cut off, or at least reduce the vacuum that's making it over to the vacuum modulator. So to test that, what we can do is just disconnect one. So we'll start here with the E port / P, and I'll plug that in, and remember that's the one that's right at the throttle body, so at the throttle plate. So I'll go inside and start the engine, and then I'll bop the throttle, and you'll notice that we will get some vacuum right here on the gauge. And then what I'll do is I'll swap over to this R, and I'll do the same thing, and we'll also see a little vacuum. On the R, you got to flip it real quick, because remember that R is out a little bit further. So first we'll do this here, which as you can see is the P port, P/E. I'll start her up. Now watch the gauge. I'll give a little throttle. Now I'll swap to the R. Now with the R, I'm going to have to kind of flip it. I'm going to have to flip it. You see, if I hold it steady, you won't see it, but you got to give it a little flip. So that test tells us that we are getting flow through here. If you were not able to see any kind of flow through there, then you might have obstructed passages. Probably the easiest way to clean obstructed air passages here would be to remove this hose here. Like you saw earlier in the video, you can look at my EGR valve video to see how to do that if you've never done it before. Remove that hose, and then you can just pull these hoses back and spray some carb cleaner in here, and that will leak through, and then you can clean the ports from the inside. Just go in with a rag and clean them, and just do that until you know that those passages are clear. So now we'll go ahead and put this back together, and we will get into the more specific, less general tests. So P to E to P and R to R. The first test we're going to do is real easy, and we are going to test the EGR valve directly. So all we're going to do is disconnect this hose with the white band. Just disconnect that from the EGR valve and pull it out. And we're going to use the hand pump here to apply vacuum directly to the EGR valve. And what we're expecting there on a good test is we're going to turn the engine on and she'll be idling. When we throw vacuum on here, that's going to open up the EGR valve. A bunch of exhaust gas is going to come into the intake, and she's not going to be able to continue running normally, and she'll stumble and stall, probably stall. So what we're testing here is the ability of the EGR valve to hold vacuum on the top, the diaphragm on the top, to make sure that it's enough to pull the pintle up. And also we're checking that there is enough of a passage for exhaust gas to get through both the pipe that goes up to the EGR valve and then through the EGR valve itself. The reason this is a good test to start with is because we're testing one component only. We're only testing the EGR valve with this test. The vacuum source is going to be the hand pump, so we're not testing the vacuum modulator. We're not testing the VSV. We're only testing the EGR valve. So what this is going to look like is just as if I had the vacuum pump right here, and I plug it in. Okay, watch the pintle there and the vacuum gauge. You'll see the pintle's moving up with very little vacuum. See that? Just a couple inches mercury there. And it's just about maxed out at about, yeah, 3, maybe 3, not even 5 inches mercury there. So I'm adding vacuum, and I'm not getting any more travel on the pintle. And that's what we're going to be expecting to see when we apply vacuum to the EGR valve that's on the body. We just won't be able to physically see the valve open, but we'll be able to deduce that the valve is opening if a whole bunch of exhaust gas gets in there and causes her to stumble. So I'll go ahead and start her up. Here we go. Got a little bit of vacuum on there. Just a little. And she's having trouble. And she's having a lot of trouble. And she's dead. Okay, so what you saw was actually a good result, even though she stalled. She stalled because of all of that exhaust gas coming in there when it shouldn't have been. So that means that this EGR valve is working well. I'm just going to put this white band back in where it was. Now if your Rav4 EGR valve fails this test, then it's time to stop the tests and get in there and take your EGR valve off and see what the heck is going on with your EGR valve. Because a normally functioning EGR valve will open when vacuum is applied to this port. If it is not opening when vacuum is applied to that port, there is a problem. There might be a leak at the diaphragm up here, so that the top of the diaphragm isn't holding vacuum. In that case, you can't repair that situation. You'd have to get a new EGR valve. Or it might be that the pintle is all stuck up with carbon and stuff, and the pintle is not able to move. Sometimes in that circumstance, you can clean the EGR valve and just reuse it after cleaning it. Another possibility might be that the exhaust passage is so clogged up with stuff that you're not even getting exhaust gas in which case your EGR valve might be working fine and it might have actually opened, but you didn't know it because there wasn't any exhaust gas getting through. But no matter what, if your Rav4 EGR valve fails this test, it's time to stop, get in there and pull the EGR valve off and figure out why either exhaust gas is not even making it to the EGR valve, or why the EGR valve itself is not acting as it should be. You can check the pinned comment for a link to my video on how to remove and clean the EGR valve and also the pipe. In case you want to know real quick though, it's super easy to remove the EGR valve on the Rav4. You just have to remove this 12mm nut right there, and then there's another one just like it on the other side. And then down here on the top of the pipe to the bottom of the EGR valve, there's just two 10mm bolts. Just take those both out. There's one hose that's down on the bottom connected to the that connects it to the vacuum modulator, and then this hose on the top, and that's it. It'll come right off. There are two gaskets, one gasket to the intake and then one gasket to that exhaust pipe, and that's all there is to it to remove the EGR valve. So if your EGR valve passed that test and you're getting a P0401 or P0402, but especially a P0401, the next thing we'll check is the VSV. The VSV is not energized when the key is out of the ignition and the car is off, like this state, but it is energized, or it's supposed to be energized, when the key is in the ignition and it's in the on position. So to do this first test, have the key out of the ignition. It's very important that the key is out of the ignition. And what we're going to do is we're going to make sure that we cannot sustain vacuum all the way across this circuit when we put vacuum on this yellow hose. So we'll leave this white hose open, just leave the white hose open just like that, and bring in the hand pump, and we'll just put the hand pump right here onto the yellow hose, and we want to see that we can't hold vacuum. So here we go. Let's see. You see I can't hold vacuum across there, and that's good. What that is telling us is that the EGR VSV is acting properly right now, because what it's doing is it's in the non-energized state, and in that state it's going to allow vacuum to reach all the way over to the EGR valve. So if we have this open, that we're venting that, so we can't sustain vacuum. So as you would guess, then if we cover this, so if I just have the same setup and I just cover the white hose, I should be able to hold vacuum. And you can see there that it is holding vacuum. So this is the proper test results for when the key is out of the ignition. The VSV should not be energized, and so when it's not energized, it should allow all the vacuum on the yellow band to make it over to the white band. When I release my finger, you'll see we'll lose the vacuum. So if you do this test and you see that you right away, right off the bat, if you do this test with this open, so you do the first one we just did, and you can hold vacuum, so you get vacuum on here, that's a VSV failure. The reason is because that means that that VSV failed in the energized state, even if it's not energized. It failed in that state. There's a solenoid inside, and they can fail in different positions. So that is pretty much a surefire VSV fail. In that case, you're going to want to get a new VSV. Now, if you do the second test and you are not able to hold vacuum, let's say you apply vacuum, but it keeps leaking and leaking, that's either a failure of one of these two hoses. You could have a big vacuum leak in this hose, or a big vacuum leak in this hose, or you could actually have a vacuum leak at the VSV. So that would require a little bit more investigation. You would need to go ahead and at least remove the vacuum hoses and test each one from the VSV, and then remove the VSV itself and make sure it's airtight. Now the second test that we'll do is with the key on. We don't need to run the engine, but just put the key to the on position, that position right before it will turn over. And that is going to energize a normally functioning VSV. And when the VSV is energized, it should not allow vacuum to make it all the way over no matter what. So in that case, any vacuum that we apply here on the yellow hose, we should be able to hold vacuum. So I'll go inside and turn the key to the on position, and then we will repeat that first test. So you remember when we did this test the first time, with this open here, we could not hold vacuum. Now with this open and the key in the on position, the VSV is energized, so we will be able to hold vacuum. And the reason we can hold vacuum is that the VSV is preventing the connection to this hose. So this is a good result for the key on. Now what I'll do is I'll go in, I'll turn the key off, and you'll see that we will lose all that vacuum. So you see that we lost all that vacuum, and that's because by turning the key off, I turned the VSV off. When the VSV is off, it is connecting this port to this port. This port is open to atmosphere because I didn't have my finger over it, and that's why we lost the vacuum there. So if your VSV failed that test, meaning that with this white band hose open and the cue onto the yellow band hose with the key in the on position, if you are not able to pull vacuum like that, that means one of two things. It either means that you have a massive vacuum leak in this hose here, the yellow band hose, or what it most likely is that your VSV is broken, and that it's broken in the open position, which is the non-energized position. So when you're trying to pull vacuum on it, even though it is energized, it's not responding. It's acting as if it's not energized. It's acting as if it's off. So a way that you can test that and eliminate the possibility that it would be a vacuum hose is if your VSV fails the test that we just did with the key in the on position, So with this open, you can't hold vacuum when you should be able to. If you cover this up and you are able to hold vacuum, then you know that your hoses are good, but your VSV is not. Now, a second ago I said 2 possible causes if your VSV fails this test, but I should say 3, because since the VSV is acting as if it's not getting power, and that's why it's failing the test, there is the possibility that it really is not getting power. And to rule that out, what I would do is take the VSV off and bench test it. If it passed the bench test okay, then I would go back to the circuit. There's a blue connector you'll see later. It's just got two connections on it. One is for power and one is ground. I would just hook a meter up to that, turn the key on the ignition just to the on position like we just did. And if that was getting power, at that connection and the VSV was performing well on the bench, then I'd go back to maybe suspecting the VSV, because sometimes they get old and they can act up and they can have intermittent failures. The electrical circuit for the VSV is just power and ground, and it's the ECU that supplies the ground. So that means there's a possibility that you could have a bad ECU in that case. I think that would be pretty rare. I would be looking more at all of the wiring on the circuit back there, the grounds and everything on the way back. So that's the other thing. That's the third thing, would be that maybe the VSV really isn't getting power. So that would be another thing to check if you fail this test. Next test, we're going to test a little on this component here. This is the vacuum modulator. These tests are real easy. You're just going to need a length of clean hose, because we'll have to just blow some air into one side. So for this test on the vacuum modulator, all we're going to do is disconnect this Q port again, the yellow band, and we'll disconnect these two sides here for P and R. We'll just leave those open like that, and put the clean hose on here so you can blow into the other side of it. And we're going to be blowing in air at Q while covering up these 2 ports with our fingers, and we should be able to hear the air coming out and venting. And what that'll tell us is that this vent's not obstructed, and it also tells us that the diaphragm is not stuck in some type of up position. So cover up both of these here and blow into the other end of the hose and listen for air coming out the top. Okay, so that is good. That means that this is not getting, the diaphragm is not stuck up, because if the diaphragm was stuck up when we blew in air at Q, then it would be preventing the air from venting and it would be pushing up against P. So if the diaphragm was stuck in an up position, when we blew in air from Q, it would just be pure resistance. Next, what we'll do is we'll start the engine, and we're going to get some of that exhaust back pressure on the bottom of this valve. And as you know, that exhaust back pressure is going to push the diaphragm up, and when that exhaust back pressure is pushing the diaphragm up, and we repeat this test, it should be the opposite effect. It should be very hard to blow in here. We shouldn't be able to pass air through here. So the next test, we'll start the engine, do this all over again, just kick a little on the throttle, and you'll see what I mean there. So let's go ahead and start the engine. Now I'm just going to blow into the other end of this hose and cover up those ports, and it should be very difficult to blow air through there. I shouldn't be able to do it. Oh yeah, and kick a little on the throttle. So what you just saw there with the engine running is the opposite result that we got with the engine off. With the engine off, I was able to blow air through here, covering up these 2 ports, and it was venting out the top. But with the engine running, that exhaust back pressure on the positive side was pushing up the diaphragm on the bottom of the vacuum modulator, and that was closing this P to Q. So when I'm blowing air in the Q side here, I'm just going up against pure resistance. So that is a good result. So let's say you got a bad result here, and with the engine running and a little bit of throttle, you were able to easily blow air across here. Well, what that's telling you is that the bottom of the T is not sealed. So probably the little seal, the little seat in the middle of the diaphragm is broken, or even if that is not broken, you could have a leak on the perimeter of the vacuum modulator. In either case, that could lead to a P0401, which is EGR flow insufficient, because you're not going to get vacuum over here like you should to open up the EGR valve. So if your vacuum modulator fails this test, you're going to want to go ahead and pull it off, Like I said, real easy to do. Just pull it off, disconnect the hose on the bottom, and then skip forward to the bench tests for this. So we'll get everything hooked up back how it should be. This yellow band should go on the Q port here, and then this hose on the inside, so it goes to the E port, should go over to P, and the hose on the outside should go to the R port. And we'll move on to the next tests. Now these next tests will require either a hand pump with the vacuum gauge like this, or just a standalone vacuum gauge like this. You'll see me using both, but they work the same way. You'll mostly see me using this one just because it's bigger and easier to see, but you can do the exact same thing with your hand pump. You just won't be pumping it any, you're just going to use the gauge side. And you'll also see that later in one of the tests in the video. You'll also need to make a T, so you'll need a way of teeing in 3 hoses. So you can get these plastic connectors. If you get this thing like from Harbor Freight or anywhere else, it'll come with a couple of T's. And you want to make a T-junction like this because we're going to be tapping into different hoses to get the values off of those different hoses. So this will, for example, these two will go back into, for example, the Q port to the VSV, and then we can tap the gauge in here, and that'll allow us to read the vacuum on that hose. And just as a tip, when you're building your T, since you're going to have a lot of connections, make sure after you do your first connection that you stop and make sure that's holding vacuum and seal it if it's not, because you don't want to build up the whole T and then find it's not holding vacuum and then you can't figure out which one it is. So here's my T, just that I'm going to use that to get some vacuum readings, and I'll show you it is airtight, so we know I'm not going to introduce any vacuum leaks. Holding the other end there. And that looks good. You see everything is hooked up normally now. What I'm going to do with the vacuum gauge, again, you either use this one or your other one if you don't have one of these. I'm going to hook into Q. So I will go ahead and T into Q. So I'm just going to take this side, plug it in. That'll be that connection, and let's get this in here. And now we'll be able to measure what kind of vacuum we're getting on Q. You want to make sure you're still doing this with the engine cold, because we don't want to have EGR flow, but we want to test that we are getting vacuum over here. You can see that I'm teed in to this line here, so this is that line that comes out of Q and just goes right there to the VSV. So if we followed this hose down, we'd end up at the VSV. This is the only vacuum gauge that you need on here to do this test, but just for demonstration purposes, I'm also going to throw the other vacuum gauge on this hose, which is going to be on the other side of the VSV. And the reason I'm going to do that is to show you the function of the VSV. Because remember when we were talking about how the VSV works, in the energized state, the VSV will interrupt vacuum from Q to the EGR valve. So when the VSV is energized, we will see vacuum on Q, but we won't see vacuum on the EGR valve. And if I hook up another gauge, you'll be able to see that. So here you can see I'm just teed into that hose from the VSV. That's the hose from the VSV. Normally that white band would go right into the EGR valve. I just teed in the vacuum gauge. And I'll just put the gauge over here so we can see it when we do the test, and we'll have 2 values. But you don't need 2 gauges for this. It's just kind of nice to show the demonstration. What you're really going to be looking for on this test is you're going to be looking for vacuum on Q. So your T, where you're teed in on the hose that goes from Q to the VSV, that's where you're going to want to see vacuum. Because the engine is cold and we're going to be idling, we do not want to see any vacuum over here. If we don't see vacuum over here, that's going to tell us that the VSV is working correctly, because it's not going to allow the vacuum that's at Q to make it to the EGR valve, because if it did, it would open the EGR valve and she would stall. So I'll go ahead and start the engine now. Now I'm going to grab the throttle. Watch this and watch this. What that result tells us, as you saw, is that we were getting vacuum here. So vacuum was making it from the throttle body along this hose here, which is the hose that comes out of the E port on the throttle body and goes into the P port on the vacuum modulator. Vacuum was making it all the way to P, it was making it across the vacuum modulator over to Q, and we were measuring it on Q. That's that vacuum that we saw. However, the VSV was not letting that vacuum get over to the EGR valve. That means that the ESV was energized. Because remember when we did that test before, when we were checking the 3-in-1 test, we had no power to the VSV, and we were able to hold vacuum from Q to the EGR valve. And that's correct for the VSV. When it has no power, it should allow flow. But when the VSV does have power, it shouldn't allow flow. And that's what you see here. So what you saw here was the ECM grounding the VSV. The grounded VSV was venting to atmosphere. So all the vacuum on Q, and you saw we were getting good vacuum, all that vacuum on Q was not making over to the EGR valve. That's why the EGR valve stayed closed. It had no vacuum on it. Now let's say that you had a bad result. Let's say that you were not getting vacuum over here, and you just had one vacuum gauge, and you were not getting vacuum over here. Well, there's two culprits that you could see there. For number one, you don't have to think about the VSV in that situation, because you wouldn't know what the VSV was up to if there was no vacuum on Q. You would be looking at one of two possibilities. The first one being the EGR vacuum modulator, or the second one being a constriction in the exhaust back pressure, so the exhaust passages. To hit the first one of those, the vacuum modulator itself, if it fails to seal, it will not seal that little T from P to Q, and so you'll be venting. So if there's some type of break in the seat of the diaphragm where it goes up against that T, it won't allow the vacuum at P to make it to Q, and you won't see any vacuum over here. Second possibility is if the back pressure from the exhaust is not adequate, you could have a perfectly functioning vacuum modulator, but it's not getting enough back pressure. Like let's say there's a clog in that exhaust line. Let's say it could be all filled up with all kinds of carbon. It happens. And it's not enough back pressure to lift the diaphragm. And if the diaphragm is not getting lifted, it's not going to close P to Q, because we have no contribution from R when we're at those low RPMs. So when we're at low RPMs, we're only going to be looking at what we're getting off of the E port in the throttle body. So that's what you'd learn from a bad result where you didn't get vacuum here. But let's say you did get vacuum here, and you ran a second gauge, and you also were getting vacuum here. What that would tell me in that situation is that the VSV is not, it's either not working, or the signal to it from the ECM is not getting to it, or there's a bad ground or something. Because if you're getting vacuum on both of these lines when the engine is cold, that means that you're getting a EGR, you're getting exhaust gas recirculation with a cold engine. It'll be running pretty rough too. The engine's not going to sound good when that's happening. But the VSV is supposed to be preventing the vacuum from Q making it all the way over to the EGR valve. So if the VSV malfunctions, that could be a cause on that. But it would also be anything that would contribute to the VSV signal, which would also be the MAP sensor or the ECM. Probably, very likely though, just the VSV. The other possibility is, let's say you had vacuum here, and you had a second gauge, you had no vacuum here, but the engine was running real rough, as if you were getting exhaust gas back in. In that case, I would be thinking, okay, you might have a stuck open EGR valve. The EGR valve might be kind of stuck. The pintle might be so packed in with carbon deposits that it can't seat all the way, in which case you basically have a constant exhaust leak back into the intake. In that circumstance, it's gonna run, the engine will run rough in all cases that you would not expect EGR flow. The only time it's going to actually feel good is when it would normally be under EGR flow. And idling cold is not one of those cases. Idling cold with exhaust getting back into the intake is going to make for a very rough idle. Now for the next test, we're just going to take this T and move it right over there. And since I already have that T in there, I'll just pull this T out, and you already know the results that we're going to see because you've already seen it. But if you only have one gauge, you would just want to T in. So T into this line, the white band, T into the line between the VSV and the EGR valve, And as you already know, we're going to want to see no vacuum there when we idle with a cold engine. So I'll go ahead and start the engine. So you saw we had no vacuum there, and that again is telling us that the VSV is working correctly. The VSV is preventing this vacuum on cue from making it to the EGR valve. You're only going to do this test if you are actually getting vacuum at cue, obviously. Because if you did the last test and you weren't getting vacuum at cue, just stop right there, because you're obviously not going to see any vacuum on the EGR valve, because that is downstream. But this is the result you want to see. No vacuum at the EGR valve when the engine is cold and idling up to 2500 RPM. Just bop the throttle. Okay, so we'll go ahead and pull this T out, and now I'm going to take her for a little spin and get her warmed up. And I'll make sure everything is hooked back in. So make sure that your white band is in the EGR valve, your yellow band is on the Q port, and that your P is to E and your R is to R. And just take her for a little spin, get her warmed up to operating temperature, and the next set of tests we'll do with the engine warm. Okay, she's all warmed up now, so I'm going to tee back into that white banded hose here for the EGR valve. So I'm just going to go in right here and tee in here. You can see I'm teed in here just like before, just like the last test. But unlike the last test, now that she's warm, we're just going to want to see a tiny little bit of vacuum here, maybe about 3 inches mercury or so when we rev the throttle. So I'll go ahead and start her up now. And now I'll just rev the throttle. Watch there. So you saw there that's different than when it's cold, because when it was cold we didn't want any kind of vacuum over here. We didn't want any vacuum flow across the VSV when it was cold. When it was warm, we just wanted that little bit. So now that she's warmed up, we will get some vacuum over on this side, but as you saw, you just want about 3 inches mercury or so. And as you saw when I was hitting the throttle, just taking it up to about 2500, 3000 RPM or so, it'll hold for a second and then cut off. And that's what we're looking to see. That means that the VSV is responding to the signal to close and the signal to open. Now if you did not get good test results here, if you did not get vacuum when you blip the throttle and the engine is warm, if you were getting vacuum over here at Q, then you know that there's something going wrong with the VSV. So that VSV is staying closed, which is energized, when it shouldn't be. If you're getting very high vacuum over here, it could also be the VSV. In that case, it would be the VSV failing to energize, because again, when the VSV energizes, that's when the flow is stopped. So if you're getting high vacuum and it's not cutting off, all that vacuum from Q is making it across the VSV. You're going to be getting too much exhaust gas into the intake in that case. Also, obviously, because we're now in VSV area, that's the electronic part of this EGR circuit, you're going to want to look at all the grounds, the wiring, all of that stuff to the VSV. I have that T out now. Everything is just hooked up normally. So for the next test, what we're going to do is we need the full intake vacuum source onto the R port on the vacuum modulator. So I'm going to use this hose here. This is the hose that goes up to the MAP sensor and then into the intake. So we're going to get we'll get full intake vacuum on this hose. So I'm going to tee into this hose and then just plug the other end for the moment. Then I'll also tee the gauge into the Q port. So for that first part, getting full manifold onto the R port, I'll use this hose, and I will disconnect the MAP sensor hose up here, and I'll tee into that. So we'll tee into that right there, and then hook back up one side of the hose to the MAP sensor, and the other side of the hose will be our full intake vacuum source onto R. I'm just going to put a plug in that for right now. So there's my plug, and the reason I'm plugging this will be a huge vacuum leak when we start the engine up, and she might not start if I don't have this plugged, so I will leave that plugged in there. Then I'm going to tee the gauge into the Q line, just like we did before. So that'll look just like it did before. Just tee right into that line for Q. Okay, so there you can see I am teed in with the gauge to Q, and I have the plug on the other end of the manifold source. So what we'll do next is, again, you want to do this when the engine is still warm. I will start the vehicle up, and then quickly I'm going to squeeze this to keep the vacuum leak as minimal as possible. Pull out the plug and put it on R, and then hit the throttle. And we're going to want to see very high vacuum here on Q. We're going to want to see nice high vacuum on Q. What this is going to simulate is that that second case scenario, how the vacuum modulator works, which is when the suction on R is enough to pull the diaphragm up. So we're going to test that. We're going to test that ability of R to pull the diaphragm up by this test. Put the plug back in and start her up and see what we get. Other thing I'll mention before I start her up is that when we do that and we get that full vacuum on Q, we're going to get exhaust gas recirculation, which is going to cause a ton of it, which is might cause her to stumble and misfire a little bit. So don't be surprised if that happens. Go ahead and start her up. And squeeze this as much as I can. Keep the vacuum rate down and go right in here before she stalls. Give her a little throttle. And there you saw and heard. Let me shut her off. So there you heard how she was stumbling and misfiring, and that was confirming that we were getting exhaust gas in there, and she was having some trouble, which is what we would expect if we had a properly functioning EGR valve and a properly functioning VSV that was getting a ton of vacuum across Q because of us importing all of this vacuum from the manifold directly to R. So that's another 3-in-1 test. There's 3 components that are being tested there. We're testing the vacuum modulator, the VSV, and the EGR valve. So let's say you got different results. Let's say that you did not get high vacuum over here on Q. Well, what that could tell you is that there's a problem with the top part of the diaphragm on the vacuum modulator, because as you'll see later with the bench testing, if this vacuum modulator is working properly, when we supply vacuum on R alone with no exhaust back pressure at all, we could have that completely open, no exhaust pressure at all. Vacuum on R, it should be enough to pull the diaphragm up and close the bottom of the T between P and Q. However, if there's a leak in the diaphragm, or if the seat in the diaphragm is broken, no amount of R is going to be able to pull it up because it's just going to be leaking, right? So if you're not getting, with full intake manifold vacuum on R, if you're not getting vacuum on Q, then you need to pull the vacuum modulator out and proceed to the bench tests. Another bad result you might have gotten, though, is maybe you did get Q, you did get vacuum on Q, but you didn't get any of that stumbling that you saw. So you got high vacuum on Q, but you didn't get any stumbling. Well, that will tell you that the EGR valve is not opening. Obviously, the EGR valve, it's possible the EGR valve is not opening because of a problem with the VSV. If it isn't the VSV, then you would be looking in that circumstance at the EGR valve, and maybe it's really stuck. It's so coated with all kinds of stuff that it can't lift up, or there's a leak in the diaphragm, and so the EGR valve itself can't hold vacuum. Another possibility with that is that the EGR valve does open, but all of the passages are so obstructed with stuff that the flow is so tiny that it's not enough to cause the engine to stumble. And in both of those cases, though, you'd be looking at taking the EGR valve off and possibly the pipe as well, and making sure there aren't any obstructions in it. We'll take all these T's out. So we'll take this T out of here. We'll put the yellow band back on Q. And we do not need the vacuum gauge anymore, so we'll just get this out of here completely. We'll also hook R back up, so we'll come back in here with the R hose and hook R on the vacuum modulator back up to the throttle body. So get that in there. And then we'll go ahead and take our T out of the MAP sensor hose. We'll get the MAP sensor hooked back up just like that. Make sure that's in there. So everything is 100% back to normal. The vacuum hose from the MAP sensor to the intake is in place. Q, the yellow band is on Q. R is in place to the throttle body, and the white band is on the EGR valve. And now we'll quickly go through some bench tests on each component. You have already seen a few times with the EGR valve that we should be able to apply and hold vacuum on the top, and what we're doing there is we're checking the movement of the pintle, make sure it goes up, that it's not stuck with carbon and stuff, and we're also checking that this is nice and airtight back here, that diaphragm. So you want to be able to hold vacuum and watch that pintle move up, and as you can see, we can see both of those there. If you can't hold vacuum, make sure that you don't have a vacuum leak at your hose. If you're positive that you don't have a vacuum leak at the hose, then it's time to replace your EGR valve, because you can't repair that diaphragm once it starts to leak up top. If you are getting vacuum and you just have a real clogged up EGR valve, a lot of times you can just go ahead and clean that. You can check out my EGR video for a little detail on that. Second test on the EGR valve is just to make sure that we can get exhaust through here, that there's no obstructions. So you just want to put a clean hose in the bottom and blow in the other side, and with that valve down, you'll be expecting all the air to come out this side. And then go ahead and close this and blow into it, and make sure that you can't pass air through it. And I can't, so that's good. If you were able, with this closed, to blow air in here and you heard a leak up here, that means that that pintle is not seated all the way. That could be because there's a bunch of carbon in there, or it could be because that the spring isn't returning as well as it should. So you can try to clean it up and see if you can get it to seal, but if you can't get that to seal, it'll be time to replace the EGR valve. It's very important that that EGR valve will completely close, otherwise you'll have a constant exhaust leak back into the intake. Another way you can test that seal is to cover this up and fill this up with carb cleaner in here and watch the level, and if the level does not leak, then you've got a good seal there. And then you'll move your finger and just pour the carb cleaner out like that. By now you're very familiar with this, the EGR vacuum modulator, and you already saw me earlier in the video pop the top off just like that. Underneath, of course, there's that little filter, so we'll remove that filter. Just get in there and remove this filter. Remember, on the one side of the filter there was some deposits from the vent, because this is effectively a planned vacuum leak here. So what we're going to check on this is those two ways of sealing the bottom of the T from P to Q. Remember, the diaphragm has to move up, and it can either move up from exhaust back pressure or from suction on R. So we'll first test that exhaust back pressure situation. To do that, I will be the exhaust back pressure. I'll just put a clean hose on the bottom side here, and I'm going to be blowing air into, so I'm going to be blowing air into the bottom side. We'll blow on the other side, but put it right up next to your ear, and you can hear the diaphragm move. You'll feel a little tiny bit of air vent through that port. That's just the air that's being pushed up by the diaphragm when it moves. It's a faint sound, it's just kind of doom, doom, like a little drum. So I'll put it on the microphone side of the camera and see if I can get it. Here we go. So hopefully the camera picked that up. It was just a slight drum noise, and that means that that diaphragm is moving up. And also when you're blowing into the other end of the hose, you shouldn't hear any kind of air leaks. So you blow as hard as you can. You shouldn't hear any air leaks. If you're hearing an air leak, it's because there's either a break on the diaphragm seal around the perimeter, or that seat, usually that little seat, the rubber seat in the middle is the thing that goes, and you'll be blowing air through from the bottom to the top, and it'll be coming out that vent. So that's the first test to do there. Now as far as testing across P to Q, what we'll do is the same deal. We'll blow into this side to get the diaphragm to go up, and we'll make sure that we can hold vacuum from P to Q. So I will hook up the vacuum gauge over to P, and I'll cover Q up with my thumb. I'm going to blow in the other side of this and see if I can hold vacuum across that. Here we go. Okay, as you can see, we can hold vacuum. The reason the vacuum went down is because I stopped blowing into this end, so the diaphragm went down. So that's a good result. If you remember, the next way we could get the diaphragm to come up was from suction on R, and that was with no back pressure. So we'll remove this completely. And I only have one vacuum pump, so my supply for R is going to be the vacuum cleaner. So I'll hook a hose up here. You'll hear me switch the vacuum cleaner on, and I'll keep the vacuum gauge on P. And with the vacuum cleaner going and nothing here on the exhaust, so no exhaust back pressure, we should be able to pull the diaphragm up with R, and we should be able to hold vacuum across here. So I'll go ahead and hook that up and switch the vacuum cleaner on and see what we can get. So here's the hose from the vacuum cleaner. I'm just going to put that on there, and you'll hear the vacuum cleaner. It will be loud. I'll turn it on, and then with my finger over Q and the bottom open, we'll see if we can get hold vacuum across there. So you saw there that we were able to hold vacuum across there, and it wasn't until the vacuum was completely shut down and we lost suction on R that we lost vacuum here, and that's because that diaphragm went down, and then we were no longer able to sustain vacuum there. So that is a good test result. Now I will remove the vacuum cleaner, and I'll just show you again the function of this as a sort of leak with nothing. With this open, with nothing on R, and with P covered, you'll see that we're not going to be able to get vacuum because we're going to be venting through there. In this situation, the diaphragm will not be up, so the bottom of the T will be open. So we'll just be sucking air in with the vacuum pump. We won't be able to hold vacuum. You see that? And that is the normal function on that. When we were doing the in-engine tests, where we were blowing air in here and covering these two ports, the first test that we did with the engine off, we went like this, covered these two ports and blew in, and we blew air right out that hole. And that's a correct test. That means that the diaphragm is down when it should be. If we weren't able to blow air through here, or if when you're doing this bench test you're not able to blow air through here, then your diaphragm might be stuck in the up position. So it might have this T closed from P to Q, and in that case you're going to have vacuum getting on Q and you shouldn't. So that would be a bad test. But if you got what we just saw here with covering these both of these ports and blowing in here and getting air out the top, that is a good test. So conversely, if we cover up that vent and blow air in here, we should not be able to get any air out. And we can't. So that means that when we do that test there, we're checking the perimeter seal around the diaphragm. So if you did this and you were certain that you had that covered up, and you had this all tacked down and you blew air in and you heard air leaking, then you might have a leak on the perimeter. So this EGR vacuum modulator is good. It's holding airtight on the bottom. It's holding airtight on the top. When we cover up the port and cover up R, we're getting the diaphragm to move up with exhaust back pressure, and we're also getting the diaphragm to move up with vacuum on R. To put this back together, you just take the filter with the coarser side facing down, and then just pop the lid back on. You'll see it's got the wider section there for the side with 2, and it just snaps right in place. The last component we have here is the VSV. We've done some testing on this as well. The first thing we're going to do is check resistance across the terminals. You see we only have 2 terminals there. So we're going to check resistance, and we are looking for 33 to 39 ohms. So I'll just take these end connectors and slip them on here, just as it makes it a little easier. Okay, and then here's the meter. We are on ohms, and let's check what we got here. Looking for 33 to 39 ohms. Oops, so you can see. And there we have 37.8. So we'll just call it 38. So we are good. So next test, we're going to check to see that there's no continuity between each terminal and the body. So we are going to, just as shown here, we're just going to check terminal to body and then terminal to body. And we want that to come back as infinite resistance, which is no continuity. So we will go terminal to body, and you see that is an open circuit, no continuity. That's good, that's what we want. Same with this one, terminal to body, open circuit, that is good. So you already know that when the VSV is not energized, as it is right now, it's not energized, we should be able to hold vacuum from here to here. So let's test that. So I'll just keep our same color codes going on, and I'll do yellow on this side, the side closest, and that will be our vacuum source, right? Because we're going to be pulling that way. That's where Q would be coming from. And then I'll just put the other hose on this port. This would be the port going to the EGR valve, or you don't have to put a hose on there if you don't have one. But I'm just going to cover this up with my thumb, and with no power on this VSV, we should be able to hold vacuum. So you can see we're holding vacuum there. If in this case you're doing this and you're not able to hold vacuum, double check that your vacuum hoses are good. If you're sure that your vacuum hoses are good and you don't have a vacuum leak in your connection, then you might have a vacuum leak internally in the VSV. And unfortunately, it's not possible to fix that. So if that were to occur, you would have to replace your VSV. You need this VSV to be airtight across these terminals when it's in the non-energized mode, and then it's going to be airtight from this way when it's in the energized mode. So what we'll do now to make sure that it's not obstructed, there's a little test you can do, which is just to put a hose on this side and just blow through the other side of the hose and make sure that it is properly venting out here, which you can see this VSV is venting okay. If you did that when the VSV was not energized and you were not able to blow air from here to here, that means that something's gone wrong and your VSV has failed in the closed position. You can't repair that. You would have to get a new VSV. The next test we'll do on the VSV is to make sure that we are able to get that change in flow when we energize it. Same as the test that we did earlier in the vehicle with the battery, but I'll just replicate it again here. So to do that test, I'll just put a hose here on this port, the port closest to the filter, the vent, and I'll hook up an alligator clip. So this is a positive, we'll put positive right here. And make sure you have some electrical tape on your alligator clips if you're using alligator clips like me. I will also put the negative on, but it's not hooked up to the battery yet, neither of these. So I've got my negative on there. Now I don't like shorting batteries, so what I will do is hook these up to the multimeter to make sure that I'm just getting the resistance across those terminals and I didn't get a short there. So you can see I'm just in ohms down here. I'm just going to make sure that I am not shorting down there. So I'm going to be expecting about the same resistance values as we have before. And you can see there I've got 37 ohms, so that is good, so I don't have a short there. So now I can go ahead and hook this up to the battery, and the way that'll work is I'll just hook up, so here's the battery here. See, I just have a hanger here. I'll just hook up the positive first on this battery, and make sure I got a good connection there. I won't be able to get it all in the frame, but the way this test will go is I will blow air into this side of the hose. So I'll blow air into the hose here, and when I don't have this energized, and you'll see this in my hand, that means I don't have it energized, I should be able to blow air through here and it should come out here. So let's try that. So that's good. That's the result we want to see. Now when I go ahead and energize the solenoid, you'll hear the solenoid click, and instead of the air coming out here, the air is going to come out here. So we won't be able to get that flow across here. So here we go. I'll start blowing air in, and then as I'm clicking it on and off, you won't be able to see it, but you'll be able to hear it here. So here we go. So that is a good result. You heard as the solenoid was kicking on that the flow was changing from here to here and here to here. So that's what we want to see. So this is a good VSV. So now, since we have all these parts, we got a VSV and a vacuum modulator, and we have an EGR valve, some hoses and a battery. Let's hook up a little mini EGR circuit here. So no doubt, by this point in this long video, you are very familiar with this EGR circuit. And so you remember that this was the hose from the EGR valve to the bottom of the vacuum modulator. That's our exhaust back pressure source for the bottom side, so to speak, the positive side of the circuit. Put that lid all the way on there. Then next we had a hose with a yellow band coming out of the Q port, and that went onto this side of the VSV, and just like that. We had a hose with a white band coming out of the VSV near the exhaust there and into this port on the EGR valve. And that's what our circuit looked like. We had power and ground to the VSV, which we'll get hooked up in a little bit. So this should look pretty familiar. What's missing? Well, let's throw some exhaust back pressure on there. They are actual exhaust to be recirculated. I will be playing that role by just blowing into this. And then now, of course, we need some vacuum. We'll do both versions of the vacuum source. We will do vacuum just on P, and you remember that was without anything on R and enough exhaust back pressure. We should be able to get this EGR valve to open. So we'll go ahead and do that first. So I will hook up the hand gauge to this here, and I will blow into the other end. I will be the exhaust of this right here. I'll be the exhaust back pressure. And once we get that EGR valve up, it'll be a bit of a battle because I won't have so much back pressure going to the EGR valve. Some of it's going to be venting out. Just pretend this is the invisible intake here. But we'll get to see how this circuit works with the VSV unenergized. So you're going to want to watch that pintle and the vacuum gauge. Here we go. And there you have it. So that's the case of the exhaust back pressure being adequate, pushing up the diaphragm on the vacuum modulator. That's closing the bottom of the T from P to Q. So the vacuum that we're applying with the hand pump at P is making it all the way to Q. The VSV is not energized, so it's allowing that flow to make it all the way to the EGR valve and pulling the pintle up. Now I'm going to hook up power to the VSV, and we'll do that again, but with the VSV cycling on and off. Alright, I have this VSV hooked up with power just the same way as before. I just don't have it energized right now. Again, I'm going to be the engine exhaust back pressure, so I'll be blowing in to this hose here. We're going to get zero contribution from R, so that's going to be when the throttle plate is before we reach that R port. And we will see what this looks like and imagine how it is when the car is running. So here we go. So there you see the teamwork, so to speak, between the vacuum modulator and the VSV as far as controlling the EGR. So I was being the ECU whenever I would connect this to close that circuit and energize the VSV, and that, as we know, is going to cut off the EGR flow, and you saw that play out. So now let's try this with the R source. So For that, I'm not going to offer any exhaust back pressure. I'm just going to pull this out, and so we won't be able to hear anything coming through, but we will be able to see whether the pintle is going to move up or down. In this case then, what I will do is I will throw that vacuum cleaner back on the R port. So I'll have the hand pump still on P, and I'll have the vacuum cleaner on R, and we'll do the same thing with the VSV, switching it on and off, and we'll just look and see what happens with the pintle. So there's the vacuum cleaner on R, hand pump is still on P, and my role is just to play the ECU by energizing and de-energizing the VSV. Here we go. So you see what was happening there? That was as we expected. No exhaust back pressure, so we didn't have anything blowing out, but we could see the valve moving up and down, and that vacuum on R was adequate to pull the diaphragm up on the EGR vacuum modulator, closing P to Q. So we did have vacuum here, and then it was just up to me whether I wanted to close that or open that, close that or open that, pretending to be the ECU. With the VSV working properly, it was cutting off the vacuum to the EGR valve, and that valve's pintle was falling down. So that'll just about do it on the EGR system for the Rav4. If you made it to the end of this very long video, sure to be very long video, thanks for watching. I hope you found it helpful, especially if you're doing some troubleshooting, or maybe you were just curious about how this system works. If you are doing some troubleshooting and you need a little help with replacing some parts, check out the pinned comment or the description. I'll have a video up within a few days of this video which will show how to find, remove, and test the VSV and how to put it on its new location. If you find that your VSV fails, where this is on the Rav4, it's so difficult to reach. What a lot of people do is they actually just leave the old one in place. They buy a new one. They pull the vacuum hoses off the old one because this bolt is super difficult to reach, and then they move it to a location on the firewall. That's what I'll show in that video, but I'll also show how to get that bolt out because I just moved mine. I didn't replace it all the way. Other video will be a video on removing the throttle body, testing the idle air control valve, which wasn't discussed in this video, but that video will also show you how to remove the EGR valve. But again, it's very easy. It's a very easy job to remove the EGR valve and to clean it. You've already seen everything you need to know, I think, about the vacuum modulator, and you saw it's super easy to remove and to test. So hopefully you've got your bases covered now. And again, thanks for watching. Please like the video if you found it helpful. Leave any tips, comments, or questions in the comment section, and good luck with your repair.